So today we are going to do the past paper MCQs from 2017 to 2021 from the lesson Organic Chemistry. So when we talk about the lesson, Organic Chemistry is a theoretical lesson. Like if you know the theory properly, then you can do the question. But knowing the theory only is not enough to do the question. You have to practice and you have to know the approach to each question. Okay. So I'm sure you all have already now to this point, you all have completed the organic chemistry lesson. You all have studied. And also I'm sure like you all have done these past paper questions. But the important thing in this session is the approach to the question. You all have to grab the approach to the question and how I'm using the techniques which I'm using to answer each question and uh, to save the time. I will be using some shortcuts, but not many because this is a theoretical based subject. So if you know the theory, you all can do this. And with the practice, so let's go with the questions. So if you all have done the paper already, okay, it's very good. But if you all have not done, no need to worry. Just go with me. I will be taking you all first through the question and then through the answers. Yeah, so let's start. So please give your full concentration to this. This is not like any other past paper discussion. Um, in this discussion, you all have to grab the techniques and the approach that I use for each question. So in that way, you all can save time for the exam paper for other challenging questions. Okay? Right. So first off, let's start with the 2017 first question. What is the IUPAC name of the following compound? And they have given us this compound. So now we all know there are rules to follow when we need to find the name of this IUPAC name of this compound. The first step is the priority order of the functional groups. Now, what is a functional group? Functional group means these additional groups which are attached to the carbon chain. This is the carbon chain, hydrocarbon chain. So to that hydrocarbon chain, if there are additional groups attached, they can be either functional group or either substituent group. Depending on the priority order, we have to understand which is our functional group and which are our substituent groups. So now let's go to the priority order. Now in this, what are the groups that now we are having the carbon chain? What are the additional groups that are attached? A carboxylic group is there, carboxyl group is there, and C2CH3 is there, and a hydroxyl group is there. Now we need to find what is the order of this. According to the order, we have to find what is the priority given for this. Okay. So this one I took from your resource book. Now according to this, we can see carboxylic acid. Yeah. Carboxylic acid is having, now this is a decrease in order. So the highest priority you can see here is carboxylic acid. So the general rule is for the highest priority functional group, we have to give the lowest possible number. When we are naming when we are naming the carbon chain, for the highest possible functional group only, we have to give the lowest number. Okay. Here, highest priority group should get the lowest number. Now, here the highest priority group is carboxyl group. So, carboxyl group is getting number 1. Not carboxyl group. This is the aldehyde group. I'm sorry, this is not carboxyl group. This is aldehyde group. So, it is having a higher priority than the hydroxyl group. Therefore, it is getting the lowest number, number 1. While selecting the longest carbon chain. This is the longest carbon chain. So while selecting this longest carbon chain, we are putting the lowest number to the highest priority functional group. Got it? Okay, so number 1 there. And we have to number such that the double bond, triple bond is also numbered. Now here there is a triple bond. So we have to consider this also. We can't go this way because then this will become a substituent group. No, then we don't have a name for this substituent group. So in order to include this triple bond only, we have to number. So because now aldehyde is the functional group, the suffix will be L. The last part will be L. And the longest carbon chain has 5 carbons. Here 1, 2, 3, 4, 5. So the carbon chain's name is pent. And the triple bond is present between C4 and C5. That means how we are writing pent 4 YNL. Or we can write as 4-pentanal. Right? Now that is the stem name. After that, we are going to name our substituent groups. What are our substituent groups? Ethyl group and the hydroxyl group. So hydroxyl group is on the third carbon, therefore 3-hydroxy. And the ethyl group is on the second carbon, therefore 2-ethyl. Now, irrespective of the front number, we are considering the alphabetical order of these names. Now, E comes before H, therefore 2-ethyl, 3-hydroxy, and then the stem name, Pent 4-enal. So, according to that, what is our answer? Answer number 5. Okay. Did all of you all understand that? Answer number 5. Okay, I hope you all understood. If there's a problem, put a message in the chat, okay? Okay, let's go to the next question. Which of the following is not a resonance structure of aniline? Now, aniline means this is the molecule. Okay, now we are going to draw the resonance structures for aniline. If we draw, I'm sure you all are familiar with drawing resonance structures by now. So, this is how the resonance goes in aniline. So, according to this, now this structure is the most stable Lewis structure of aniline. Here, it is the most stable Lewis structure of aniline. So, according to this, 3, 4, 5, and 1 is correct. That means they are correct resonance structures. 3, 4, 5, and 1. See, in this question, we just have to draw all the resonance structures of aniline and eliminate the correct ones. They're asking which is not a resonance structure. No. So, which is not a resonance structure means these are resonance structures. So, we can eliminate 1, 3, 4, and 5. So, then 2 is the answer. But we'll just check and see the composition. So, if we consider the second one, there are 5 electrons around this carbon. Therefore, here there should be a minus mark. But in our second answer, there is no minus mark here. Only the lone pair is there. So, second one is a wrong resonance structure. So, that is the answer here. Okay. Right. Then the third question, consider the following reaction. And they have given us this reaction. They are asking us the product of this reaction. Right. Okay. So now I have taken all this data from the resource book. Okay, I have even indicated the page numbers. So I will be sending this PDF later, or you can go through, okay, separately. So now when we take a unsaturated aryl compound, aromatic compound, if this is the first substituent group, these are the positions. There is ortho position, meta, and para. Ortho means these two sides of the substituent group. Meta means here and here. Para means directly below the substituent group. Okay. During SE, what is SE? Electrophilic substitution. Electrophilic means what? It likes electrons. So the molecule should be a plus charge one, right? So during electrophilic substitution, the second substitution takes place based on the nature of the first substituent group. This is the first substituent group. Second substitution to this molecule will take place based on the nature. Nature means what? Based on the directing ability. So there can be that substituent first substituent group can be of two types, orthopara directors as well as meta directors. What are the orthopara directors? In our syllabus, these are the orthopara directors. Okay. Out of them, these 3 are strongly activating the benzene ring. Orthopara directors, except halogens, the orthopara directors' role is they are activating the benzene ring. That means they are increasing the electron density of the benzene ring. Okay. But except halogens. Halogens are orthopara directors, but it will decrease the density of the benzene ring. Okay. It will deactivate the benzene ring. Then when it comes to meta directors, these are the meta directors. Meta directors are deactivating the benzene ring, or we can say that they are reducing the electron density of the benzene ring. So now they have given us what is our reaction. Br2 FeBr3 is being added to this molecule. Right, Br2 FeBr3 means this is what is happening. Br2 is there, Br is there, and FeBr in FeBr3, in Br2 there will be delta plus and delta minus, right? So when FeBr3 comes, FeBr3 also has delta plus, delta minus. In that the Metal is the anion. Metal is having the partial negative charge. So if we will have delta minus and Br will have delta plus, and this is the unstable molecule. So from this, what will happen? The Br will get attached with FeBr3 and leave, and this will become Br plus. Right? So that is how I have got this Br plus here. Now this Br plus is the electrophile. It is plus, so it likes negative charges. So it likes means it is the electrophile. Now it is going to get substituted. So it is called as electrophilic substitution. So when we consider this molecule, if we divide this from here, this is a ketone group. Ketone group means what? It is a meta-director. So if it is a meta-director means what? It is deactivating the benzene ring. That means the electron density of the benzene ring will be reduced due to this ketone group. Keeping that in mind, we'll go to the next portion. Next portion is the ether part. Ether means it is an orthopara director. Orthopara means what? It activates the benzene ring. Activating means it's increasing the electron density of the benzene ring. So now Br plus is there. It is our electrophile. It lies places where there is higher electron density. So which portion of the molecule it will get attached? This side or this side? This side, right? Because here only the electron density is high. Therefore, it attaches the part with the greater electron density or the greater activity. Therefore, that means it attaches to this ether part. That means now ether is an orthopara director, right? So this Br have to get substituted in this side. And orthopara means where should it get substituted? Here, here, or here. Okay, it cannot come to the meta positions, right? So now we'll consider our answers. So now we know Br should come to this side. So this is wrong, and this is wrong. See, from this, we can eliminate 1, 2, and 3. From just the fact that Br is an electrophile, and about if we have the knowledge of this orthopara directing groups and meta directing groups, we can eliminate 3 answers. So from that, we have 4 and 5. So there's a 50-50% chance of getting it right or either losing it, right? So that is much better. Okay, so when we come to now we are left with 4 and 5. Now we know this ether group is an orthopara director. But if we consider this fourth one, here it has got attached to the meta position. So can it get attached to meta position? No. So this is wrong. Then the answer is answer number 5. Here it has got attached to the para position, but it can also get attached to the ortho positions as well. So here the answer is answer number 5. Right? Okay. How was it so far? Are you all understanding? Is it too fast? Can someone put a message, please? Or continue in the same speed, okay? Okay. Fourth question. Compound A reacts with lithium aluminium hydride to give B. B is more basic than A. B liberates nitrogen. B liberates nitrogen when treated with NaNO2HCl at 0 to 5 degrees Celsius. Both A and B react with ammonical silver nitrate to give precipitates, and the structure A could be. Right. So in this type of a question, now we don't know what is A, what is B. We don't know what is A, first of all. We have to know what is A. So my advice is just start with the first molecule and take it through this process and check whether it's giving the answer. Most probably in this type of questions, it will be the first answer, but just to make sure, you all can check the other answers as well. So it is safe, I can say, to start with the first molecule and take it through this process. All right? Right. So when it comes to lithium aluminum hydride, it is a strong reducing agent. Strong reducing agent. And it undergoes, it causes nucleophilic addition reactions. Okay. So if there is a amide with lithium aluminum hydride, nucleophilic addition means the short way to remember it is this double bond breaks and 2 hydrogens will get added across this double bond and oxygen will leave. Just remember like that. There is a separate mechanism for this. Okay, and you all have to know why we are adding lithium aluminum hydride first and H plus H2O second without adding them together. But for now, for the MCQs, remember that if reducing agent is there, that means what is happening is this double bond is breaking and two hydrogens are getting added across this double bonded carbon. Okay, so if there is a amide, now here there is a double bond. Now across this double bond, two hydrogens will get added. Then what will form a primary amine? If there is a ketone, a secondary alcohol will be formed, right? The other thing to remember is if there is an amine, this oxygen will also leave, right? But if it is a ketone or an aldehyde, then the oxygen, nothing will happen. Just hydrogens will get attached to here and here, right? So ketone means it will give us a secondary alcohol. Aldehyde means when it reacts with lithium aluminum hydride, it will give us primary alcohol. Right, so now I said, now we'll take the first molecule. So when we take the first molecule and we reduce it, now what will happen? This one does not have that carbonyl carbon. Carbonyl carbon means carbon attached to oxygen, carbon double bonded to oxygen. This one doesn't have that partner, so nothing will happen to this. This one cannot get reduced, okay? This one can get reduced because it has a carbonyl carbon. So what happens for amines? Now this is an amine, okay? This is an amine. So what happens when amine, this is a amide, sorry, this is a amide. So what happens when amides are reduced, it will form primary amines, right? So here that has that double bonded oxygen, two hydrogens has got added. So here that primary amine part is there. Now this part, nothing has happened, so it will be like that. Now this is our compound B if this is the A compound, right? Now they are saying for this B compound, if we add NaNO2 and HCl at 0 to 5 degrees Celsius, it is forming another compound and liberating nitrogen gases. Okay. So now if this is aniline and if this is the condition, aniline means here NH2 is attached. If aniline means and if this is the condition, then the diazonium salt will be created. But this is not aniline, this is the amine, just the amine. So when amine reacts with this, it will form this group will be converted to a hydroxyl group, right? And this group, nothing will happen with NaNO2 and HCl, so that will stay like that. So it will be converted to a hydroxyl group and nitrogen will be released, right? That's what is happening when this for this B when we add NaNO2 and HCl. Okay. And the next one they're saying is for this A and B both, if we are adding ammonical silver nitrate, it will form a white precipitate. White precipitate or the silver mirror precipitate. Okay. So now this for this, if there's acidic hydrogen, it will react with this ammonical silver nitrate and form the precipitate. Acidic hydrogen goes with this and it forms NH4 plus, right? And no, sorry. Acidic hydrogen goes with this and it forms HNO3 and this Ag plus will get attached to this carbon, right? So it will form this precipitate, which is a white color precipitate, or we can say it is a silver mirror precipitate. Same way to this also, this part is there, so it has acidic hydrogen, no? So that same reaction will take place and it will give a white color precipitate, right? Okay. So now this first molecule we considered as A is answering to all these tests and giving all the relevant results. So we can say that the answer is answer number 1. This answer. But we'll just go through the other answers as well and how is this answer justified. Okay, so now when we consider this primary aliphatic amine, this is not an aliphatic amine, this is an aromatic amine. No, this is an aliphatic amine because here no, it's attached here. So this is a aliphatic amine. This is a primary aliphatic amine. So when we add NaNO2 and dilute HCl, it will form the diazonium chloride. Alkyl diazonium chloride will be formed, but that is unstable. Even at low temperatures, it is unstable. If it is aniline means at low temperatures, this diazonium chloride is stable. But this is not aniline, no, this is an amine. So even at low temperatures, it is unstable. And when we add water to it, it will form the alcohol and release nitrogen gas and HCl. Aromatic diazonium chlorides from aniline are stable at lower temperatures, like I said. Okay, so when we consider this and this, now they have given us a statement in the question. B is more basic than A. We'll consider that B is more basic than A. Now this is our B, this is our A. Now in A, this is the amino. So this now if there is a carbonyl group, delta plus delta minus is naturally there. But this amine part has the lone pair. So this will give the lone pair to this. And at the same time, the delta plus electrons are getting more attracted to the delta minus. No. So these electrons will get pulled towards this side. That means the ability to donate the lone pair of electrons is less in A than in B. Right? So if in B, what is happening in B, this amine compound is there, this whole benzene ring, through induction, it will give high electron density onto this nitrogen. So there is more tendency to release the electrons from this nitrogen in B. So ability to donate the lone pair is high in B than in A. That means what basicity of B is greater than the basicity of A. So B is more basic than A. That's what they have said, right? B is more basic than A. So according to our answers, our first compound gave this result. So it is the first answer. Right. So let's go to the fifth question. Right, here I have given why the other answers are not correct. You all can go through separately, okay? Right. So let's go to the fifth question. In fifth question, in this reaction scheme, we have to identify what are the P, Q, and R structures, right? So the first one is, molecule, this molecule is what? This is an aldehyde. So to an aldehyde, when we add OH minus, what is the product? That is our first step. Now to in an aldehyde, the carbon adjacent to the carbonyl, this is the carbonyl carbon, right? Due to this carbonyl carbon, there is an electron withdrawing nature. Why is that? Because oxygen is there. So oxygen is delta minus, carbon is delta plus, right? So due to that electronegativity difference, the electrons will be more withdrawn towards this, like this way the electrons will be more withdrawn. Due to this electron withdrawing nature of this group, the carbon adjacent to the carbonyl carbon, that means this carbon is getting an acidic nature. This carbon's hydrogens are getting the acidic nature. This carbon is called the alpha carbon and this hydrogen is called the alpha hydrogen. This hydrogen is acidic. Why? Because of the strong electron withdrawing nature of this carbonyl group. Right. So now when we are adding aqueous sodium hydroxide, what's happening? Aqueous sodium hydroxide means we know it is giving OH minus, right? So that OH minus is having the lone pair and this minus charge. So it will attack on this hydrogen, this acidic alpha hydrogen. Then this will give the lone pair to this and this will become a minus carbon. Now this will leave with this OH and form water. Now a carbanion is formed. This is called a carbanion. And it is minus. Minus means it likes positive charges. So likes positive charges means it is a nucleophile. Now this nucleophile can again react with this aldehyde. Okay, this nucleophile. Here this nucleophile reacts with this aldehyde. I said no, this is delta plus, delta minus. So this minus charge of this carbanion will attack this delta plus and this bond will break. So it will form O minus and this will become plus in the presence of this. So this gets attached to this plus carbon here and oxygen will get minus. So this is our P compound. Okay. O minus should be there in our P compound. But in our given any of the P compounds, now this is respectively, so this line is P, this line is Q, this line is R. But in any of our P compounds which are given, oxygens are not minus anywhere. All are having OH. That means what they have gone to the next step as well. What is the next step after this P compound is formed? It reacts with the water. So when it reacts with water, water is having H plus and OH minus. So that H plus is reacting with this minus and forming the OH here. And OH minus will get released from this water molecule. So this is the given P. All right. This is the given P. So from this, what can we eliminate? First, see what can we eliminate. CH3, CH, CH2, CH. Okay. So we can take this as the answer, this as the answer. Wait. Oh, no. We can't take the first one as the answer because it's CH3, CH2. No. This can be the answer. This can be the answer. This can be the answer. So from there, we can eliminate 1 and 5. Now we have to just check between 2, 3, and 4. Right. Okay. So we'll go to the next step. Next step, what are they saying now? After P, they have added H plus to get Q. Now we have our P. This is our P. To this P, if we add H plus, what will happen? H plus means it is a dehydration reaction. This means now we are having an alcohol now. This is an alcohol, right? A secondary alcohol. Now adding H plus means we can't add H plus anymore here. No, this is not a reduction. No. H plus means it is a dehydration reaction. You all have to understand by this step, they are meaning a dehydration of the alcohol. Okay. So dehydration of the alcohol will take place. Dehydration means what? Removing water. So this OH and this adjacent carbon's hydrogen will get removed as a water molecule, and a double bond will be formed between this and this carbon. I hope you all are familiar with it already now, the mechanism of this, okay? So that resulting product is called the enol, and this is our Q, right? So after P identified, we took 1 and 5 as wrong answers. Now we have our Q. From 2, 3, and 4, we can disregard this because our double bond is coming here. So now we have our right. Now we have our Q as well. Now what is the next step? Sorry, that was Z. No, I cut. Yeah. We can cut this. So now we are remaining with 2 and 4. Now we have to now we have to check the R compound, not Z. Yeah, R compound. Right. So now for the Q compound, that means for this compound or this compound, when we add Grignard reagent and H plus, what will happen? Right. So Grignard reagent, this is a polar covalent bond. So it has delta minus and delta plus. Right. So Grignard reagent can act as a strong base as well as a strong nucleophile because it has this delta plus. Strong base, why? Because it has this delta minus. Right. So now this is our Q compound, and if there is a carbonyl group, I already explained that there is delta plus and delta minus. So this CH3MgBr, this is minus, no, this carbon is minus, delta minus. So this delta minus will attack on this delta plus. At the same time, this will get removed and form O minus. This bond will get break and it will form O minus. So to this O minus, this MgBr is having delta plus charge. No, once this CH3 breaks, MgBr will get a complete positive charge. So that positive charge MgBr will get attached with this O minus and form OMgBr. And for this delta plus carbon, after this bond breaks, it will become a complete plus. So this complete minus gets attached as complete plus and forms this compound. Now this is our compound. Now they are saying along with the, now only if the Grignard reagent is added, this will be the compound. But along with the Grignard reagent, we have added H plus. That means what? If we are adding H plus, now this part is plus. This oxygen will get minus. So this H plus will react with this group and form OH, and what will leave? MgBr plus will leave. So this is our R compound. So according to that, now from 2 and 4, this is our R compound, right? So what is the answer? Answer number 4. Okay. I hope you all understood that. If there's any problem, let me know. Right, let's go to the 6th question. Now they have given us this reaction with HBr. Alkene is there, alkene reaction with HBr. If you all know the mechanism, you all can easily answer the question for this. Right. So here I have given the mechanism. Alkene is reacting with HBr. HBr is a polar molecule, it has a dipole. So delta plus will be the hydrogen, delta minus will be the bromine. So what is the electrophile here? H plus is the electrophile. Where in the presence of HBr, this alkene is an alkene. The double bond is electron-rich part. So this electrophile will attack directly to this double bond. Okay. So in the presence of the alkene, this will get polarized. In the presence of the alkene, this will get polarized into delta plus, delta minus, and this delta plus will attack the double bond. Then this Br minus will leave. So in the step 1, what happens? The delta plus attack this. Then this is not a double bond anymore. According to the Markovnikov's law, hydrogen will get added to the side where there is more, which carbon has more hydrogen. The carbon which has more hydrogen, to that side only hydrogen will get attached. Now in this one, hydrogen is more in this side, right? So the hydrogen will get attached to this carbon. Then this carbon will get plus. Here hydrogen got attached to this carbon. Now this carbon will get plus. Now this Br minus removed from HBr. Now that Br minus will attack to this carbon plus and it will form this compound. This is our P. So now what is the electrophile? This is the electrophile and it got added, right? Nothing got substituted. This is an electrophilic addition reaction. So here they are saying this is a nucleophilic addition reaction. So it is a wrong statement. P is the major product. Major product, minor product, we have to see according to the Markovnikov rule. The Markovnikov's rules, according to Markovnikov's rule, if we get a product, that product is the major product. Markovnikov's rule means what? To the carbon which has the more hydrogen, only hydrogen will get attached. So this is the major product. Now we'll see where this is the P they have given. Yes, it's the same molecule. So P is the major product, is a correct statement. Right, this is correct. And a carbocation is formed in the first step of the reaction. This reaction is taking place in 2 steps. In the first step, electrophile is getting attached. And in the second step, the Br minus gets attached to the carbocation. So here carbocation is formed. This is a secondary carbocation. Carbocation is what? A plus charge. Carbon is there. So a carbocation is formed in the first step is a correct statement. Q is not the major product. Q is the minor product. P is the major product. Q is the product formed if HBr is added according to the anti-Markovnikov's rule. So B and C is correct means what is the answer? Answer number 2. Second one is the answer for 6. 7th question. Which of the following reaction steps is or are most unlikely to take place when chlorine reacts with CH4 in the presence of light? Right. So chlorine reaction with CH4 is what type of reaction? It is a free radical addition reaction, right? In the presence of UV light, these reactions will take place. Now, if you see the resource book, they have given this full mechanism properly. They have given all the chain propagation steps, chain initiation steps, then chain termination steps. Likewise, they have given all the reactions step by step. Now here, I'm not going to discuss all those reactions and all. I'm just telling you how to approach this question. So for this, you all no need to know the entire reaction mechanism. The point here is, in this entire reaction mechanism, there is no H radical. H radical cannot form. H radical is, it's an unstable molecule. Anyhow, it will not form, not only in this free radical addition reaction. Anyhow, in nature, H radical does not form. It is an unstable thing, unstable molecule. So it will not form. So wherever there is H radical, that means it is wrong. That answer is wrong. It cannot happen. All other possibilities can happen. Right? All other options can happen. But H plus radical means from there itself, you all have to identify that it is unlikely to take place. So wherever there's H plus radical, it is unlikely. Here also unlikely. Now they're asking most unlikely in which C and D is the unlikely one. Why? Because of H plus radical. So C and D is the answer means, what is the answer? Answer number 3. Okay, here I have not given an explanation. The whole mechanism is there in the resource book. The point here is H plus radicals are created means it's wrong. H plus radicals are unstable, so H plus radicals cannot be formed. So those two are unlikely. Answer number 3. Right. Eighth question. It is not possible to prepare Grignard reagent by reacting this compound with magnesium in dry ether. Grignard reagent does not react with compounds having a hydroxyl group. Okay. Now here you all need to know the theory. What are the reactions of the Grignard reagent? No need to by heart. Go with the basics. With the basics, now you all already know Grignard reagent is having a basic nature. It can act as a strong base as well as a strong nucleophile. So from that theory, now we'll see how to build up the answer. So if there is an alkyl halide and when we add magnesium triether, the Grignard reagent will be formed. But in the process of forming a Grignard reagent, why we are using dry ether? Why can't we use just ether? Why should it be specifically dry? Because if there is water, this reaction will take place. Water is acidic, right? So it is having H plus OH minus. That H plus reacts with this R group, which is a delta minus charge and forms RH. And this MgX part reacts with the OH group of water and forms MgOHX. So since this reaction is taking place, we cannot form a Grignard reagent if it is having water. That's why it should be specifically dry. The same thing takes place if there is a H plus. No need to be water. If there is a H plus also, the same thing will take place. So Grignard reagent cannot be formed in the presence of a hydrogen H plus acidic compound or if there is water. So it has to be dry. It has to be free from acidic hydrogens or polar groups. Therefore, compounds cannot be with acidic hydrogen cannot be used to prepare the Grignard reagent. So if we consider our given compound, this is the given alkyl halide with a hydroxyl group, not really alkyl halide. So it has a hydroxyl group. Hydroxyl group means what? This hydrogen is acidic. That means what? It is going to react with this. It is going to react and it is going to react with this magnesium triether is going to react with this hydrogen of this alcohol group, and therefore the Grignard reagent cannot be formed. See, this reaction will be taking place, right? Since the OH group is acidic. So the first statement, what is the first statement? It is not possible to prepare Grignard reagent by reacting this in magnesium triether is a correct statement because this compound is acidic. Magnesium triether, magnesium will react with this. This Grignard reagent will react with this and it will magnesium triether will react with this and it will not form the Grignard reagent because this compound is acidic. So the first statement is correct. Grignard reagent does not react with compounds having a hydroxyl group. Yes, that is also a correct statement. Wait. No, sorry. Grignard reagent does not react with compounds having a hydroxyl group is wrong. Because based on this justification, we went to this answer. Because it reacts with the hydroxyl group only, it is not possible to prepare Grignard reagent. So this is obviously wrong. So first statement correct, next statement wrong means answer number 3. Right. Then let's go to the 8th question. We did the 8th question, right? So let's go to the 9th question. What is the IUPAC? Now we are in 2018. In 2017, is everything clear? Okay. Let's go to 2018 then. 2018, 9th question. Right. Ninth question. What is the IUPAC name of the compound shown below? Now they have given us a compound. Now we have to find the IUPAC name. Just follow the basic rules. First find, whenever there's a compound, just go to the functional groups. After going to functional groups, figure out the priority order of this functional group. After that, find the stem name. After finding the stem name, consider the substituent groups. Then attach those substituent groups to the stem name. That's all you have to do in the IUPAC name. Right. So this is the highest priority group, functional group. So it should get the lowest number. So we put 1, 2, 3, 4, 5, 6. This is the way to number. Then these are becoming the substituent groups. Now this is the carboxyl group. So the chain name will end with oic acid. Here there has to be a space, okay? Oic acid. It's not one name. And then when we consider the stem name, now there is a double bond between C2 and C3. The lowest carbon number only will come when we are naming. So hex 2, there are 6, so it's hex 2E. In second carbon, there is a double bond, oic acid. That is the stem name. Now we come to substituent groups. Nitro, 3 nitro, 4 bromo. This is how we are naming the substituent groups. This naming of substituent group is also there in the resource book, okay, in a table. And now we know the substituent groups. Now we are going to name it in the alphabetical order. So B comes before N. So 4 bromo, 3 nitro, hex 2 enoic acid. So the answer will be answer number 2. Hex 2 enoic acid can also be written as 2-hexenoic acid. Right. Then 10th question, which of the following statements about phenol is false? 1 second. Okay. Which of the following statements about phenol? This is phenol, right? C6H5OH is phenol, which is false. Now we have to find the false statement. Okay, let's go to the analysis. Right. What is the first statement? Reacts with CH3COCl to form a phenyl ester. Reacts with an acid chloride to form a phenyl ester. Usually alcohols, what do? Alcohols with acid chlorides also, they form esters, right? So same way, phenols will react with acid chloride and it is an acid-base reaction and it will form a phenyl ester. This HCl molecule will leave, and to here, this oxygen containing phenyl group will attach here. So that is this molecule that is called a phenyl ester, and HCl will leave. So that reaction can take place. So this is a correct statement. React with bromine water to give a white precipitate. That is a characteristic reaction. That is a characteristic reaction to identify phenol. Phenol can react with bromine aqueous. That means bromine water. Then now phenol is an ortho para director. So to all the ortho directions and the para direction, bromine will get substituted. It is an electrophilic substitution. So 2,4,6 tribromophenol is the name of this compound. It is a white precipitate. Therefore, the second is it is a correct statement. Evolves carbon dioxide when treated with sodium bicarbonate. Right. So now when phenol reacts, phenol is an acid. So it can react with sodium and it can form the sodium salt of phenol and give out hydrogen gas. Same way, it can react with sodium hydroxide and form the sodium salt, but this time it is given water, depending on the reaction, okay? But if it reacts with sodium carbonate or sodium bicarbonate, if it reacts, now if this is a hypothetical situation, if it reacts, it will form the sodium salt and carbonic acid, H2CO3. Then this carbonic acid will get dissociated to water and carbon dioxide, that we know. But in order for this reaction to happen, this phenol group should be more acidic than this carbonic acid. But phenol group is less acidic than carbonic acid. Therefore, this reaction will not take place. Why? Because this carbonic acid is highly acidic. It is normally a weak acid, but it is acidic than this phenol. So this reaction will not take place. Therefore, carbon dioxide will not evolve. Therefore, third one is wrong. Now they are asking for the false statement. No. Then the third one is the answer. Gives a colored compound when treated with diazonium salt in the presence of sodium hydroxide. We'll just check those answers as well. Here I have given the acidity increase in order as well. Carboxylic acids having a greater acidity than carbonic acid greater acidity than phenol greater acidity than alcohol. So because this is having lesser acidity than carbonic acid, it will not undergo a reaction which is giving carbonic acid. So it will not react with sodium bicarbonate or sodium carbonate. Okay. Phenol reacts with diazonium salt. This is phenol. This is the diazonium salt. It undergoes a reaction. This is in the diazonium salts, there were two types of reactions in the resource book. One is replacement reaction and the coupling reaction. Replacement reaction means the diazonium salt will get directly substituted by another group, but coupling reactions means the diazonium salt acts as a electrophile. Why electrophile? Because of this nitrogen has plus. Plus means it likes electrons, so it is acting as an electrophile. So when phenol is there, it undergoes an electrophilic substitution and HCl will get released according to this manner. And now to this molecule, now this HCl will get released, and now this diazonium molecule will get from this nitrogen, it will get attached to this para part of this phenol group, and it will form this compound. It is an orange colored compound. Therefore, the fourth statement is correct. It gives a colored compound when reacted in the presence of sodium hydroxide. Is a correct statement. Okay. Right. Gives a colored compound when treated with neutral ferric chloride. Ferric chloride. Now, this is an identification reaction of phenol. Ferric chloride is given Fe3 plus and 3 chloride ions. This Fe3 plus, it is a metal. So, it can act as a ligand. It can act as the central molecule, and this phenols acts as the ligands and forms a complex with this Fe3 plus. Here I have written acts as ligands and forms a complex with phenol. That is wrong, okay? Fe3 plus is not acting as the ligand. Fe3 plus is the central metal ion. So it cannot act as a ligand, no. So that is wrong, what I have written, sorry. So Fe3 plus is the central metal ion, and the phenol will act as ligands, and it will form a complex. That complex is purple color. So the fifth statement is correct. It will give a purple color solution when treated with neutral ferric chloride. So the answer is answer number 3. Then let's go to question number 11. Which of the following represents a correct step in the mechanism of nitration of benzene with conc HNO3 and conc H2SO4? Now this is directly from the resource book. No mechanism. You all have to have a good idea about the mechanisms of each and every reaction that is given in the resource book. Some mechanisms are not given in the resource book, like that reduction with lithium aluminum hydride. Likewise, some mechanisms are not clearly given in the resource book. So that is fine. What is given in the resource book, you all have to have a clear idea how this mechanism is happening, how what is the electrophile, what is the nucleophile. Likewise, you all have to have a proper idea. Now see, this one is coming directly from the theory. That means if you all have by heart at the resource book, organic chemistry, you all can answer this question. Other questions were not like that so far. You have to use application and practice as well. This one you all can directly answer. So mechanism of nitration of benzene, what is the correct step they are asking? Now, if we consider the first answer, in this we have to go one by one, checking which one is correct. We can't at once write the mechanism of nitration and then check, no, because no time in the MCQ paper. We are like in a kind of race, no. So to finish, so we can't write the mechanism and then check one by one. So better to go one by one answer and check the composition is correct, but the step which is happening, whether it is correct, from whether this step is there in the mechanism, we can check like that. Because we know the mechanism already in our minds. So if we consider the first one, here what is happening? NO2 is donating electrons to this benzene. Yeah, NO2 is donating the electrons to this benzene ring. So that cannot happen, right? NO2 is donating the NO2 plus is donating the electrons to the benzene ring. In the nitration mechanism, this double bond is breaking and NO2 is joining. That is what is happening. So this is wrong, right? So when we come to second one here, this is the step that should happen here. This bond should break and only the NO2 will join. But here NO2 is given, so it is wrong. The second one, this step is correct. But the next step, what has happened? NO2 has joined and here the plus has come. Right, so that is wrong. Composition is wrong. Composition of this molecule is wrong. Because now what should happen is this should break and then here it should be a plus. Here NO2 and hydrogen and here it should be a plus. But here the plus has come here. Here it can't be a plus, no, because here already there is a hydrogen here, no. Then 4 bonds are satisfied. Then it can't be a plus here. Right? So, and here there can't be an additional hydrogen as well. From where this hydrogen has come? We don't know. Right? So there can't be an additional hydrogen here. So this is also wrong. Understood? Right. Okay, so that's why the second one is wrong. In the third one is correct. This step is correct. But what is the mistake? Here it should be NO2 plus. from this reagent, we are getting NO2 plus, right? So NO2 plus only should be the electrophile. It's electrophilic substitution. So if it's NO2, it's a wrong answer. Electrophilic means it should have a plus charge because it should like the electrons. If it is plus only, it can like the electrons, right? So the third one is wrong. Then the fifth one, the carbon atom to which, check the fifth one. Yeah, fifth one also the same issue. This carbon atom has got plus. This carbon atom can't get plus because already there is a hydrogen here. No? So 4 is satisfied. Octet is also satisfied. So it can't get a plus there. So that's why the fifth one is wrong. In fourth one, yeah. In fourth one, this is the correct answer. This is the most appropriate answer. This is what is happening. HSO4 minus coming and this step is correct. But here, this arrow should come to this carbon. Right, but they have not mentioned it properly. But this is the most appropriate answer. So we are going to answer number 4. The plus carbon is not getting the electron pair. Yeah. The plus carbon is not getting the electron pair. It shows like this carbon is getting the electron pair. But this carbon only should get this electron pair from nitrogen when it leaves with HSO4 minus. So that is not shown properly, but this is the most appropriate answer we can take. Depending on this arrow, we can't decide. Depending on the direction of the arrow, we can decide. But to this carbon or this carbon, it can be a slight mistake. No, the actual thing is this arrow should be coming to this carbon. Okay, I can't draw it properly, sorry. Right, so this is the way to do it, and this is the most appropriate answer. So we are going to answer number 4. Right, so we'll come to the next question. Now they have given us a reaction sequence. We have to find what is X and what is Y. Right. So for this, we need to know 2 things about the reduction of organic compounds and the hydrolysis of the Grignard reagent. Give me a second. So sodium borohydride, NaBH4, like lithium aluminum hydride, is a reducing agent, right? But it is not a strong reducing agent as lithium aluminum hydride. So it can reduce now lithium aluminum hydride. If there's any carbonyl group anywhere, it can undergo reduction. But sodium borohydride only from the compounds containing carboxyl groups, it can reduce only aldehydes and ketones. It cannot reduce carboxylic acid because it is not that strong to reduce carboxylic acid. Carboxylic acid is a very strong acid, no? And sodium borohydride is a weak reducing agent. So it cannot reduce the carbonyl group of the carboxylic acid, but it can reduce the aldehydes and ketones. Right. So when we consider a molecule, now we are adding sodium borohydride and H plus H2O separately. Then what will happen? Carboxylic acids will not get reduced, but this ketone group will get reduced to form this secondary alcohol. I explained that earlier. So the second one is wrong. From that we can eliminate. Now we have to have a secondary alcohol in X. X should be a secondary alcohol. So 2 is not a secondary alcohol. Here this is not a secondary alcohol. So 2 is wrong. And yeah, only 2 is wrong. And nothing happens to the carboxylic acid group as well. So 5 is also wrong. Here, see, carboxylic acid group has got converted to CHO when it comes to X. So that cannot happen. So 5 is also wrong. Right? So now we have our X. Now for that X, we are adding excess Grignard reagent. Now what will happen? We'll check. When we are adding Grignard reagent can act as a strong base, I said. So if there are acidic hydrogens, Grignard reagent will react with them. Now carboxylic acid has this acidic hydrogen here, right? So because of that, this MgBr will get attached. I explained the mechanism earlier. And in alcohol also, the MgBr will get attached and this will be the product formed. But this is not the main, and CH4 will be formed. CH4 will be formed how now? This hydrogen will get released from this and this. No, that hydrogen will get attached with this CH3. Now we're adding excess CH3 MgBr. Okay, there can be 2 CH4 as well. I have not considered the balanced equation, but just the theory. Okay. From this CH3 will get attached to this hydrogen and this hydrogen. That's why no OMGBr is forming because these hydrogens are leaving. So these hydrogens get attached to the CH3 and form the CH4. Methane releasing is the major product. Methane is the major product of this reaction. But here they are considering about the minor product. Right? Here they are considering about the minor product. Wait. So what is the minor product that we got? Let me open it again. Sorry. Okay. This is the minor product that we got. So they are considered about the minor product. So what is our answer? Answer number 1. Okay, I don't have the eliminated answers and all now. It got deleted. So it's answer number 1. Okay. So let's move on to the 12th question. In this reaction sequence, find P and Q. See, now there is a pattern in these questions, right? We have to know the steps of this reaction. There's no point of by hearting all the mechanisms and structures in the resource book. You cannot answer the paper then. You have to have the practice and the wisdom to approach the question. Okay. So in this reaction sequence, find P and Q. Okay. Now we have this to this benzene phenyl group, and alkyne is attached. Alkyne group is attached. Alkyl group is attached. Now we'll check. Now, if we add Hg2 plus and dilute H2SO4, that means what we are actually adding, we are adding water, right? That reaction mechanism is there in the resource book. It's there for alkenes as well as alkynes. So when we add in water, it has H plus and OH minus. So what will be forming that now this one pi bond will get broken and it will form the double bond. Here I'm not going through the mechanism, just what is given in the resource book only. Okay, and this enol will be formed. Hydrogen will get attached and OH minus will leave. Then this enol will rearrange to form a ketone. This through resonance, this enol will rearrange to form a ketone, right? So now a ketone only should be our which product? P product should be the ketone. First products are P, second products are Q. So first product should be a ketone, means first one is wrong. Fifth one is wrong. Second one is also wrong. So now we have only 3 and 4. Again, 50-50 chance of getting it correct or wrong. So if you are at the last point of your paper and if you don't have time to think between these two, just underline one, you will get a 50% chance of getting it right. So that is the big thing, right? If you just do only this first step, you have a 50% chance of getting it right. Okay, so now we have our P. Now we'll go to our Q. For Q, what have they done? They have added zinc amalgam and HCl. Right. So zinc amalgam and HCl is also called as a Clemenson's reagent. That name is not given in the resource book, I guess. They have mentioned it as zinc amalgam conc HCl. So all aldehydes and ketones, when they react with this zinc amalgam and conc HCl, this double bond will break and hydrogens will get added across this double bonded oxygen. Then this compound will be formed. This will be converted to an ethyl group. C6H5 and the ethyl group. Therefore, what is our answer? From 3 and 4, now there should be ethyl group, right? So this is wrong. That means our answer is answer number 4. 13th question, which of the following is true regarding ethene and ethine? Calcium carbide reacts with water to form ethine. Right now, this reaction is important. Calcium, this is not a big thing. Just if we know the reaction of calcium carbide with water, we can answer this question. Calcium carbide, when it reacts with water, what does it form? If you all don't have to by heart this reaction. This is like water means you all know it's H plus OH minus. Now we are in calcium carbide, which part is getting plus, which part is getting minus? Calcium part is the plus part, carbon is the minus part, right? So the minus parts get attached with the high H plus, and the plus part get attached with the OH minus part. So calcium carbide plus water will form calcium hydroxide and C2H2. C2H2 is ethyl. Therefore, A statement is correct. It reacts to form ethyl, not ethene. So second B is wrong. Ethene reacts with ammonical silver nitrate to give a precipitate is wrong. No, ethene means the double bonded one. Double bonded ones, anyways, they do not have that acidic hydrogen. So they cannot react with ammonical silver nitrate, right? So C is wrong. Then when we come to ethine, ethine reacts with ammonical copper chloride to give a precipitate. Ethine means it is having an acidic hydrogen. No, not because it is having a triple bond. We have to see whether it is having the acidic hydrogen, because there can be some compounds which are having triple bond but no acidic hydrogen. Then they cannot react with this ammonical copper chloride and all. If they are having triple bond and if they that means they are having acidic nitrogen, means only they can react with this ammonical copper chloride to give a precipitate. Okay, so these are the reactions that this acidic hydrogen can undergo. This is based on the resource book solely. Okay, so when we add sodium and ammonia or NaNH2, we can form the acetylide ion. That means C minus sodium plus this salt can be formed, not a salt, it is called the acetylide ion. And ammonical silver nitrate means silver mirror precipitate. And copper chloride and ammonia means red color precipitate will be forming. Therefore, D statement is correct. A statement, D statement correct means what is the answer? Answer number 4. Which of the following statements are true regarding Which of the following statements are true regarding 3-hexene? Now, if they ask like this 3-hexene, we can't at once imagine in our mind, also quickly draw it in a piece of paper. Even if you can imagine in your mind, I advise it to draw in a paper and then do the question, because at the exam time, it's not safe to trust what the mind is telling. Okay, what's in your mind, the structure in your mind. Okay, so let's go to the 3-hexene. This is the structure of 3-hexene. 3-hexene means what? Hex means there should be 6 carbons. So at once draw 6 carbons. After 3-hexene, that means on the carbon 3 only the double bond should be there. Between carbon 3 and carbon 4, there should be a double bond. Right? So 1, 2, 3, 4, 5, 6. Between carbon 3, carbon 4, there is a double bond. This is the 3-hexene molecule. Now we'll go to the questions. Does not show geometric isomerism. Geometric isomerism means what? First test, okay. Does not show geometric isomerism. Geometric isomerism means to show geometric isomerism, there should be a double bond. And also, the carbons on either side of the double bond are then this carbon should have 2 different groups attached. That means this group should be different to this group. This group should be different to this group. Likewise, right? This group and this group, if it is same, even though there is a double bond, it cannot show geometric isomerism. The concept in geometric isomerism is for this each carbon, the groups attached to each of these carbon should be different to each other, right? These two can be the same. The point is this and this should be different. This and this should be different, right? And there are 2 types of geometric isomers, cis and trans. Cis means same groups are on the same side. Here, these are the same groups. Same groups of each carbon atom of this and this. These are same. This and this are same. Both are on the same side. These 2 are up. Hydrogens are down. So this is trans means it is in the opposite side. This hydrogen and this hydrogen are in the opposite sides of this molecule. This ethyl group and this ethyl group are on the opposite sides of this molecule. That means it is trans. So now this molecule, our molecule, it is having a double bond. And for each carbon, it is having different groups attached. That means it is showing geometric isomerism. What is our statement? Does not show geometric isomerism. Means it's wrong. No, it's showing geometric isomerism. Shows optical isomerism. For optical isomerism, what should it be? There should be a sp3 carbon atom. sp3 carbon atom means there should be 4 bonds. And those bonded molecules, bonded groups to that sp3 carbon atom should be different to each other. 4 different groups bonded to sp3 carbon atom. That will create an asymmetric carbon atom, or we can call it a chiral carbon atom. And also, if it is optical isomers, then they are mirror images of each other. So now in this molecule, there is no chiral carbon. Can you see any sp3 molecule which is having 4 different groups in this structure? No, right? So that means what? There is no chiral carbon. No chiral carbon means it does not show optical isomerism. So the B statement is also wrong. The compound obtained when reacted with H2 palladium does not show optical isomerism. H2 palladium. H2 palladium is what happens. It is a reduction reaction. These double bonds, across the double bonds, hydrogen will get attached. That is all. Hydrogen will get attached across the double bond. For unsaturated compounds only, this reaction will take place. Right? So there is a double bond, and H2 palladium, when it reacts, this hexane will be formed. In this, is there a chiral carbon? Can you see a sp3 carbon with 4 different groups attached? No. So that means C statement is correct. This is the C statement. The compound obtained when reacted does not show the optical isomerism. Yes, no. What we got is hexane, right? Hexane. So it has no chiral carbon, so it does not show optical isomerism. So C statement is correct. Right. Then when it reacts with HBr, now we'll react this one with HBr. When this compound reacts with HBr, what happens? Hydrogen, according to Markovnikov law, it will get attached to the carbon which has more hydrogen. But in this compound, this carbon also has one hydrogen. This carbon also has one hydrogen. So if it attaches to either of this, it will give the same molecule. So this is the molecule that it will be giving. Now this star carbon is there. Now this star carbon, see, it's sp3 and it is having 4 different groups attached. So it is a chiral carbon. That means this statement is correct. So C and D statements are correct means answer number 3. See, D statement, when it reacts with HBr, it shows optical isomerism. So now we saw that it is correct. So C and D correct means answer number 3. Right. 15th question. Yeah. CH5, C6H5Br does not easily react with sodium hydroxide to form phenol, and the phenol carbocation is very stable. Now we are coming to the phenol reactions back again. What they are saying here, what is the molecule? Bromobenzene. Yeah, this is an aryl halide. This is bromine. This is bromine. So this is the aryl halide, bromobenzene. It gets double bond nature due to resonance. Now, in all the resonance structure, if there is a monosubstituted benzene, it gets double bond nature due to resonance, due to the delocalization of the electrons. Resonance will take place and this will get a double bond nature. So in the resonance hybrid of this molecule, there will be a partial double bond nature. Due to that partial double bond nature, it will not undergo normal alkyl halide reactions. What is alkyl halide? Alkyl means what? Normal alkanes are there. Like those normal alkanes, a halide is, halogen is attached. So that is called the alkyl halide. So they do not have any double bonds in them. But this aryl halide or bromobenzene, it has partial double bond nature. So because of that, it will not undergo the normal alkyl halide reactions. Okay. So what are the normal alkyl halide reactions? I have given some. I think all which are there in the resource book is there here. So these reactions undergoing by normal alkyl halide, but not by aryl halides, right? That's what I have put crosses here. But magnesium diether, that can react with this and form the Grignard reagent, right? Now, what is the first statement? This does not react easily with sodium hydroxide to form phenol is a correct statement. Why is that? Because of the partial double bond nature due to resonance, this will not react with sodium hydroxide and form phenol. But if it was an alkyl halide, then it can happen. So statement 1 is correct. The phenyl carbocation is very stable. Phenyl carbocation. This is the phenyl carbocation. Phenyl carbocation means for benzene, 1 plus is attached. That is the phenyl carbocation. Right? So in this carbocation, if we consider the hybridization of this plus charged carbon, what is the hybridization? sp2. So this plus is there on a sp2 hybridized orbital, not on an unhybridized p orbital. Therefore, this plus charge will not get delocalized throughout this benzene ring. Why does the delocalization occur? Because of the pi electron clouds, right? Because the electrons are there in the unhybridized p orbitals, because there's a pi electron cloud at top and bottom of the benzene ring. That is why that electrons, unhybridized p electrons are getting delocalized. But this plus charge, it is not there in an unhybridized p orbital. It is there in a hybridized sp2 orbital. Therefore, it will not get delocalized. If it doesn't get delocalized, it will not get stabilized by resonance. Therefore, it will not get stabilized by resonance, right? So therefore, we can say that it is unstable. But in our question, they are saying it is very stable. So this is wrong. So first statement correct, next statement wrong means what is the answer? Answer number 3. Right. Now we are coming to 2019. Okay. What is the IUPAC name of the following compound? These IUPAC names, you all practice. Like each day write one IUPAC. Then when you go to the paper, it will be your 105th IUPAC name. So it's see the amount of practice there. So then how much time you can save there. When you're just seeing the compound itself, you can see the name. No need to count the numbers and all. Right? So it all depends on the practice. Now see, just because if you just by heart the organic chemistry resource book, you can't answer this question. It depends on the practice and the IUPAC name of this compound. Let's see. Right now we have the compound. What's the first step I said? Check the functional group and check the priority order of the functional group. Now in this, according to the priority order, I'm not going to show it again and again. Okay. According to the priority order, this is the highest priority functional group. That means what? It should get the lowest possible number when we are numbering the longest carbon chain. Right? So for that, in that order, if we number the carbon chain, okay. Now for this to get the lowest possible number, we can name from here. If we name from here, this will not get the lowest possible number. So we are naming from here. 1, 2, 3, 4, 5. And we can start from here 1 because then this can't be a substituent group, no? How are we going to name this? CH2NH2. And we have named the longest carbon chain. So all the possible carbons we have to take inside the chain. That's why we are naming here, starting from 1, 2, 3, 4, 5. So now we have done the name. And now we have identified the functional group. Next, what we are doing, we are writing the stem name. What is the stem name? How many carbons are there? 5. Then pentan. Then this is the ketone group. So it finishes with one. O-N-E. Okay, it finishes with O. And it is there in the carbonyl group is there in the second carbon. So it is pentan 2-O. There are no double bonds, so it is not pentene or anything. Pentan 2-O. That is the stem name. Now we are going to our substituent group. Substituent groups are amino and hydroxy. So according to the alphabetical order, 1 amino, 5 hydroxy, 2 pentanol. Right? So that will give us the third answer. 1 amino, 5 hydroxy. Okay, I said 2 hydroxy, I guess. 5 hydroxy, 2 pentanol. Then the answer will be answer number 3. Okay. Right. What is the major product of the following reaction? Now this product, we are going to react with sodium hydroxide. Right. Now, earlier I explained what reactions take place with sodium hydroxide. With sodium hydroxide, everything will react. Only with sodium carbonate and sodium bicarbonate, we have to check. But with sodium hydroxide, alcohols will not react. Yeah, so okay, we'll go with this process. Phenol is there. Phenols are acidic. So, strong acid. So sodium hydroxide are strong base. So it will react and form this sodium salt. And the phenol is not strong acid. Phenol is just normal acidic. And sodium hydroxide is strong base. So it will react and form the sodium salt and water. Then carboxylic acid. With what are we reacting? With sodium hydroxide. Okay. With carboxylic acid, if we add sodium hydroxide, it will react and form the sodium salt. Even bromobenzene won't react with sodium hydroxide. Bromobenzene won't react with sodium hydroxide. This is bromobenzene, right? So it is an aryl halide. It won't react with sodium hydroxide. Because of the partial double bond nature, it gets due to resistance. I guess I explained that enough. times, right? Okay. When we add in excess sodium hydroxide, now phenol is there. Now that phenol's OH group will be forming the sodium salt and giving water. Then carboxylic acid is all here. It's carboxylic group, carboxyl group. So this hydrogen is also acidic. So it will react with sodium hydroxide and give water, right? And give the sodium salt. But these alcohols are weak acids. Here their Ka value is 10 to the power minus 15 to 10 to the power minus 19. That means very small Ka value. So it is very weak acid. It is not acidic enough to react with the strong base. So it will not react with strong bases like sodium hydroxide, potassium hydroxide. So it will remain the same when we react with excess sodium hydroxide. So this will be our major product. So the answer is answer number 2 according to that. Right. Then 18th one. What is the incorrect statement about diazonium chloride? Diazonium chloride can be obtained by reacting aniline with this at this temperature. This is correct. Now I explained it earlier as well. And this reacts with Ki to give iodobenzene. Now this is what I said that in diazonium chloride, under diazonium chloride in the resource book, there were two reactions types, replacement reactions and coupling reactions. This iodobenzene is a replacement reaction. Here these are all replacement reactions. No, I'm sorry. These are all, yes, these are all electrophilic substitution, replacement reactions, okay. So if there is diazonium chloride, now this is iodobenzene is forming means we are adding Ki and heating. Then only this diazonium group will be replaced with iodine. So diazonium chloride replaced by iodine. That is forming iodobenzene. So that statement is correct, right? It reacts with Ki to give iodobenzene is a correct statement. This ion can act as a nucleophile. Yes, why? Because of this plus charge, it can act as a nucleophile. Electrophile, sorry. It is having a plus charge, so that means it likes electrons. Likes electrons means electrophile. So it is correct. When an aqueous solution is heat of diazonium chloride is heated, it decomposes to give benzene. Does it give benzene when it is heated? No, right? I explained it earlier. Yeah, see, when it is heated, it gives phenol, not benzene. So this is the wrong statement. This is the wrong statement means this is the answer. Fourth statement is the answer. Here, see, they are asking the incorrect statement. Diazonium chloride reacts with phenols in basic medium to give colored compounds. That is a correct statement. Normally, I showed how diazonium chloride reacts with phenol. Same way, diazonium chloride can react with beta naphthol in the basic medium as well to give a, I guess, red colored compound. I'm not sure of the color. Yeah. As I remember, it's giving a red colored compound with beta naphthol and it is giving a orange colored compound with phenol. Right, in basic medium. So the answer here is answer number 4. Question number 19. An organic compound decolorizes this and this they are given as a process. So like I said, take the first molecule throughout the process. That's what we have to do in this type of questions. So if it decolorizes bromine water, it should be unsaturated. First one they are saying, it decolorizes bromine water. We can take, now here in my analysis, I haven't taken the first molecule throughout the process because this was done a long time before. Okay, so after that, I realized that it's easier if we take the first molecule and go through the process. So now let's go along with the analysis. An organic compound X decolorizes bromine water. Decolorizes bromine water means what? It should be unsaturated. Unsaturated means what? It should be having a double bond or a triple bond. From that, now this all the compounds have double bond, triple bond, but 5 does not have a double bond, triple bond, so it is strong. See, we can eliminate one already. Next, X does not give a precipitate with ammoniacus copper chloride. That means what? It does not have acidic hydrogen, as I explained earlier. This one has acidic hydrogen. This one has here no acidic hydrogen, so this is wrong. Here no acidic hydrogen, so this is wrong. So now we are having that 50-50 chance, 1 and 4. When X is treated with acidic potassium dichromate, a green color solution is obtained. Now what color is potassium dichromate? Orange. Orange color solution is converted to green. That means this potassium dichromate is reduced to chromium 3 plus. Here chromium is reduced to chromium 3 plus. That means our X compound is getting oxidized. This and this should be having the oxidizing ability. Now, let's go to our answers. Wait. Was there a mistake anywhere? Yes. X does not give a precipitate with ammonical copper chloride. That means X does not give a precipitate means 1 and 4 is wrong. Because these people are having the acidic hydrogens. So it will give a precipitate with copper chloride. So now we are left with 2 and 3. Sorry, it does not give a precipitate with ammonical copper chloride. Means these two are wrong. These two are giving precipitate with ammonical copper. So now we are left with 2 and 3. Now we have to see whether it is oxidizable. Right. Now the theory that is H plus K2Cr2O7 is a strong oxidizing agent. Aldehydes, primary, secondary alcohols get oxidized. Ketones and tertiary alcohols cannot get oxidized further. This is a very important fact. Ketones and tertiary alcohols cannot get oxidized further. Aldehydes, primary alcohols, secondary alcohols, they can get oxidized. Now, if we come to our question, this is a tertiary alcohol, right? This is a secondary alcohol. I hope you all know how to differentiate tertiary alcohol and secondary alcohol. Here there is no hydrogen attached to the carbon, so that means it is tertiary. Here there is a one hydrogen attached to the carbon, that means it is secondary. So now we know tertiary alcohols cannot get oxidized. So can second one be the answer? No. So we are going to cancel out the second one. Now we are having the third answer. Third one is the answer. Third one is a secondary alcohol. Secondary alcohols will get oxidized. Into what? It will get oxidized to this ketone. And this will get reduced to this. Then orange color will become green color. Okay, so our answer is answer number 3. Which of the following are nucleophilic substitution reaction or reactions? Nucleophilic substitution. Now we have to have an idea what is nucleophilic substitution. Nucleophilic means what? It should be a negative charge or else it should have a lone pair. And substitution means one is leaving and one is getting replaced by that. That is getting replaced by another. Right. A is nucleophilic addition. What is A? Now here we have to go one by one to check whether it is nucleophilic substitution or not. A is what? Aldehyde and HCl. This is a nucleophilic addition reaction. All reactions of aldehydes are nucleophilic addition reactions, right? So aldehyde with HCl, this is the mechanism that takes place. Cn minus gets added on to this. Cn minus gets added on to this. And this hydrogen also gets added. This is a nucleophile. This gets added. So it is a nucleophilic addition. That means A is wrong. They're asking for nucleophilic substitution. Then this one. That is correct. Why? Because now this is the molecule they have given. It has delta plus, delta minus with PCl5 and PCl3. It will, this will get replaced. This OH group will leave and Cl will get substituted. It will replace. Cl minus is the nucleophile. So it is nucleophilic substitution. These are the products that it will form. Right. So B statement is correct. Then the next one. Alkyl halides nucleophilic substitution takes place in 2 ways, SN1 and SN2. SN1 means in 2 steps the nucleophilic substitution takes place. SN1 means, remember, like this, 1 by 1. SN2 means both together. Right? SN2 means not 2 steps. That is always getting mixed up. Even for me, it was getting confused. SN2 means 2 steps. SN1 means 1 step. But it is not like that. SN1 means all are taking place together. SN1 means step by step. One step after the next. SN2 means both the steps are taking place together. So which type of alkyl halides are undergoing SN1? Tertiary alkyl halides. Which type of alkyl halides are undergoing SN2? Primary and secondary alkyl halides. So depending on the carbocation stability only, it will depend which type of reaction this nucleophilic substitution will take place. So alkyl halides, they can definitely undergo nucleophilic substitution but it depends on the stability of the carbocation, which type of nucleophilic substitution they will undergo. And another thing, secondary alkyl halides means depending on the structure of that secondary alkyl halide, it will see which carbocation is depending on the structure of that secondary alkyl halide, it can undergo both SN1 and SN2. Okay, but primary and tertiary is strictly following this. Right. So now we have an alkyl halide and it can undergo nucleophilic substitution. So this is correct. This is a free radical addition reaction, right? With the presence of UV light, this is the free radical addition reaction. So this is not nucleophilic substitution. So B and C is correct, means answer number 2. Right? Yeah, answer number 2. Okay. Next question. Which of the following statements regarding compound A are correct? Which of the following statements regarding compound A are correct? Now they have given us this compound. Which statements are correct? We'll check. A exhibits geometric isomerism. Now to exhibit geometric isomerism, the groups on either side of each carbon across the double bond, there are 2 carbons. Now each carbon should have different groups. This is correct for this molecule. So A exhibits geometric isomerism. There is double bond and each carbon is having different groups attached. So it exhibits geometric isomerism. A does not exhibit optical isomerism. Does it have a chiral carbon anywhere? We'll check the extended structure of the molecule. Right. So when we consider this is the extended structure of the molecule. So here it has a chiral carbon. sp3, 4 different groups are attached. That means it is a chiral carbon. What is the B statement say? Does not exhibit optical isomerism is wrong. It has a chiral carbon, so it exhibits optical isomerism. The product obtained when A is reacted with pyridium chlorochromate, PCC. PCC is a mild oxidizing agent. Alcohols get oxidized to carboxylic groups and carboxylic acid, and ketones when reacted with strong oxidizing agents and ketones. Okay, to oxidize alcohols until the aldehyde PCC is used. Normally, alcohols are getting oxidized until carboxylic acids when it is reacted with K2Cr2O7. But to stop it at the aldehyde stage, we are using this PCC. So if there is alcohol with PCC, it will become the aldehyde stage. Here it is the ketone, right? This when this is getting oxidized, this won't get oxidized. No, ketones will not get oxidized, so it will remain the same with PCC. But this secondary alcohol will get oxidized to form a ketone. Now these 2 groups are the same. That means is it exhibiting geometric isomerism? No, it does not exhibit geometric isomerism. So D is the correct statement. Does it exhibit optical isomerism? No, right? It does not have a chiral carbon, so it does not exhibit optical isomerism. So C is wrong. So A and D correct means answer number 4. Next question. The reaction is a nucleophilic addition reaction. That is wrong. No, alkenes and alkynes do not undergo nucleophilic addition reaction. They undergo electrophilic addition reactions. Why electrophilic? Because they are having double bond. Double bond means electron-rich places. So the people who like electrons are only coming to the alkenes and alkynes. So who are the people who like electrons? They are electrophiles. So electrophilic addition reactions only take place with alkenes and alkynes. So it's not nucleophilic addition. So that is wrong. A secondary carbocation is formed in this reaction. Okay, now we have to go to the mechanism of this reaction. So if we take the mechanism, I explained this mechanism earlier. A carbocation will be formed and it is secondary. Why? Because for this carbon, 1 hydrogen is attached. Sorry, for this carbon, 1 hydrogen is attached. So this is the intermediate secondary carbocation. So the second statement is correct. First statement wrong, second statement correct means answer number 4. Okay. Right. Mm-hmm. Question number 23. Question number 23. I'll try to do my best. Now there's only half an hour left. No, I try to do my best. There's 2021 also. So in case I can't finish, I'll be sending the PDF to you all. Now you all can go through the PDF. And the point of this is not to discuss all the past paper questions. The point is to make you all to understand the techniques to answer each question. So I hope you all grab the techniques from the questions we discussed up to now. So I'll try my best to do the 2021 as well. If there's no time, just go through the PDF and try to get the answers. Okay. 2020, the IUPAC name of the given compound. IUPAC name, now you all know to write. First, identify the functional group. What is a functional group mean according to the priority order? OH. That means it is ending with E0. Then when we are numbering the carbons, first we have to give priority to the double bonded place. The double bonded place gets the lowest possible number. Then 1, 2, 3, 4, 5. When we are mentioning it like this, it will get pent 1 in all. That is the stem name. Then considering the substituent groups and alphabetical order of the substituent groups, we are getting answer number 5. Okay. I'm not spending much time to explain that. Now we did that several times. Which compound can undergo aldol condensation when reacted with sodium hydroxide? Right. Now this is important. There's only half an hour now. Okay, guys, so listen carefully. Aldol condensation. Aldehydes and ketones that have acidic hydrogen undergo aldol condensation. Right. Aldol condensation, the mechanism was there. It's not there here. Okay, aldol condensation means what? If there is aldehydes and ketones, and in the presence of sodium hydroxide, it will, if now those aldehydes and ketones have acidic hydrogen, no. So I think I explained that earlier, aldol condensation mechanism. Right, I can't go back again. I hope you all got the idea from that earlier explanation. In aldehydes and ketones, they have this acidic hydrogen because of that strong electron withdrawing nature of the carbonyl group. Because of that acidic hydrogen, it will react with the sodium hydroxide and undergo the aldol condensation. Right, so aldehydes and ketones which have acidic hydrogen and undergo aldol condensation. So is this aldehyde or ketone? No. So we can cut off this one. This one also we can cut off. Now in this and this is aldehyde, this is aldehyde, which is having acidic hydrogen. This one is having acidic hydrogen. This one to this carbon, 3 CH3 groups are only attached. Then to this carbon, 3 carbon atoms are only attached. So where is hydrogen attached to this carbon? There's no hydrogen. So there's no acidic hydrogen. That means it cannot undergo aldol condensation. So it's answer number 4. Okay. So we'll go to the next one, 25. Consider the nitration reaction. Okay. Again, the nitration reaction for bromobenzene this time. Earlier, they asked the nitration mechanism for normal benzene. But this is for bromobenzene, the nitration mechanism. They're asking what is not a resonance structure of this intermediates, right? So, we can draw the resonance structure for bromobenzene. And from these resonance structures, we can get the answer is answer number 3. Practice the resonance structures, okay? For benzene and bromobenzene. And for benzene and monosubstituted benzene, benzene and double substituted benzene, likewise practice the resonance structures. So then these type of questions will be easy. Consider the following reaction scheme. Find the P and Q. Now we have a molecule. We are reacting it with chlorine and aluminum chloride. Now we need to find what is the P. When we are reacting with chlorine and aluminum chloride, it is an electrophilic substitution reaction. Here, chlorine plus is the electrophile. According to that, earlier I showed Br2 and FeBr3. In that Br plus was the electrophile. No, likewise, in the same way, these two will react and it will give us the electrophile, Cl plus electrophile. Now, this electrophile will get substituted the benzene ring. This part will not react with the electrophile. Electrophile means it likes electrons, no, but this carbon is carbon delta plus. So, electrophile does not like this plus, so it will not have a reaction with this carboxyl group. But benzene is electron rich, no. So, this electrophile gets substituted instead of a hydrogen to the benzene ring. Okay, refer to the Friedel-Crafts alkylation mechanism, okay, halogenation mechanism. So it will get substituted, and since this is a meta director, it will get attached to meta positions. What are the meta positions? Either this or this. This carbon or this carbon, it will get attached. Now it has got attached this. because this is a meta director. So we can say 3, 5, and 4 are obviously 3, 5, and 4. 3. So it cannot happen like this. No substitution has taken place here. Chlorine has got substituted to this. It cannot happen because this is getting delta plus this carbon. So if this is also plus, this is also plus means electrophile means it does not like this plus, no, so it will not happen. 3 is wrong. 4 is also wrong because of that. 5, why is it wrong? Because chlorine has got attached to para position. Chlorine should get attached to meta position. Why? Because this is a meta director. So that is also wrong. Now we have this 50-50 chance, 1 and 2. Now we have to go to the Q. We are for this compound, we are adding lithium aluminum hydride and H plus H2O. That means what? A reduction is taking place, right? Carboxylic acids are not reduced by sodium borohydride. But now we are adding lithium aluminum hydride. So with lithium aluminum hydride, it will get reduced and it will form primary alcohol. Chlorine will not have an impact with this reducing agent. Okay, so it will remain as chlorine, and this is the compound that is formed, and that is our Q. Is it Q? Yeah, that is our Q. So this is the answer number 2, right? Which of the following statements regarding the reaction between compound P and HCl to form the alkyl halide is correct? Now compound P is there, react it with HCl, like the same way we did it with HBr. Just do it from the mind quickly. HBr, if it is there and if it is an alkene, it is an electrophilic addition reaction. How is the addition going to happen? H plus is the electrophile. H plus will get added to the carbon which has more number of hydrogen. That means which carbon it will get added? This carbon, right? This carbon only has 1 hydrogen. This carbon does not even have a hydrogen. So to this carbon only, that hydrogen will get attached. Then what is the product? After the hydrogen gets attached, just draw the product and name it. And see whether that name is this. Okay, now we have reacted. We have got the product. Now we are naming the product. It's 2-chloro-2-methyl-butane. Therefore, A statement is 2-chloro-2-methyl-butane, the major product. So it is correct. Major product, now that means the Markovnikov product. B, a secondary carbocation is formed as an intermediate. Is it? A carbocation is formed. Okay. A secondary carbocation is formed as an intermediate in this reaction. Is it a secondary carbocation? Now this is what is happening. Then this carbocation, this is the carbocation. There is no hydrogen attached to this C plus. That means this is a tertiary carbocation. So that means B statement is wrong. In one of the steps, HCl bond is cleaved to give a chlorine radical. That is wrong. No, chlorine radical is not given anywhere during this reaction. In one of the steps, a nucleophile reacts with a carbocation. That is correct. First step, now this takes place is 2 steps. First step, HCl breaks and this H plus is the electrophile. H plus gets added to this, gets attached to this double bond, and the double bond breaks and the H plus gets added. That is the first step, electrophilic addition. Second step, now from this HCl, when the H goes, it will become Cl minus. Here Cl minus is remain. Now this Cl minus, now this carbon is plus, no. So this Cl minus will come to neutralize the carbon plus and it will form this molecule. That is the second step. This is minus, this is plus. Minus is like in the plus, means it is what? It is a nucleophile. Like in the plus means nucleophile. So it is an nucleophilic addition will take place, right? Not nucleophilic addition, nucleophile reacts with the carbocation. Here nucleophile like. Okay. Screen is getting stuck. Oh, wait, let me open it again. Hi. Yeah. Okay, now it's uh, yeah, I can't move the tabs here. It's not. One second. Wait, I'll stop this share. Can someone tell me the question number we were doing this? Which question were we doing? We didn't do this. Right. You are here. No? You all can see my screen, right? Okay. 2020. Mm, right. This question, no? Okay, right. Sorry. Yeah, so we came to conclusion that A is correct. Of that, yeah, B is correct. Oh, then A and D correct means answer number 4. Right. Now let's go to the next question. Let's finish 2020. Yeah. All compounds having a carbon-carbon double bond show diastereomerism. Diastereomerism means what is diastereomerism? Either it should be cis or trans, right? So it can't be cis or trans if the compounds, if there is a double bond, and if each carbon, now if we say this carbon is having two hydrogens, then this hydrogen and this hydrogen are similar, no? So it is not showing diastereomerism. So that is a wrong statement. Any two isomers which are not mirror images of each other are diastereo. That is also wrong, because what if there is a sp3 carbon atom, but those are having similar groups, so they are not optical isomers and they are not mirror images. But just because they are not mirror images, they are not diastereomers because there is no double bond, right? So likewise, we can say this statement is wrong. This statement, both are wrong, right? So it's answer number 5. When we come to 29th question, hydrogenation of benzene is more difficult than the hydrogenation of alkenes. Addition of hydrogen to benzene results in the loss of aromatic stabilization. That is correct. It is answer number 1. This is explaining this statement. Addition of hydrogen to benzene results in the loss of aromatic stabilization. To a normal alkene, if we add hydrogen, it is stable, right? It can happen. It is stable. But to benzene, when we add hydrogen, that hydrogen will get delocalized, no? So that hydrogen, when it gets added to the benzene ring, normally there is a delocalization that takes place in the benzene ring. But when the hydrogen gets added, that delocalization is disturbed. So that aromatic stabilization due to the pi-electron cloud delocalization will be lost when hydrogen is added. Because of that reason, hydrogenation of benzene, hydrogenation is adding hydrogen, okay? Adding hydrogen to benzene alkenes. Adding hydrogen is difficult to benzene than to alkene. So it is the first answer, right? Yeah, first answer. Then 30th question, reaction between ammonia and alkyl halide gives a mixture of primary, secondary, and tertiary amines and a quaternary ammonium salt. Right, now this is important. Ammonia and alkyl halide. This is there in the resource book completely. I just copy pasted this from the resource book. Okay. Ammonia and alkyl halide when it reacts, but in the resource book it's given as amine reaction with alkyl halide. Now here they are asking ammonia reaction with alkyl halide. So that's what I wrote it again. Ammonia molecule is there and it reacts with an alkyl halide. So it forms a primary amine. So now ammonia is a primary amine. This primary amine, ammonia, when it reacts with this, now this R group is delta plus. Cl is delta minus. So this delta minus Cl will react with one of the hydrogen, acid-base reaction, and it will form HCl. Then this R group will attach this nitrogen plus and it will form a primary amine. But this primary amines nitrogen also has a lone pair. So this can act as a base and react with ammonia again and form a secondary amine and HCl. Right? Then this secondary amine still has a lone pair. Then again it will react with that RCl and it will form a tertiary amine and HCl. Tertiary amine also has a lone pair. So again it can react as a base and form quaternary ammonium salt. Now it does not have a lone pair, so it can't react further. This is the quaternary ammonium salt and chloride ion will be formed, right? So reaction between this and this forms primary, yes, secondary, yes, tertiary, yes, amines, and a quaternary ammonium salt. That is a correct statement. Primary, secondary, and tertiary amines can act as nucleophiles. That is correct, no, because they are having a lone pair. They can act as nucleophiles. So that is a correct statement. So both statements are correct means what is the answer? Number 1. Right? Okay. Yeah, earlier I said that this is an acid-base reaction. No, this is not an acid-base reaction. This is a nucleophilic addition, nucleophilic substitution reaction. Okay, what is that? Because this is delta, no, delta plus, delta minus. Here also it is delta plus and delta minus. So when HCl gets removed and the R group gets attachments, that is because this group is having a lone pair, so it acts as a nucleophile and it gets attached to the delta plus R group. Okay, so it is a nucleophilic reaction. Right. 8:50. So we can't discuss all the 2021 questions. So I'll stop the session now. How was the session? And give me your honest comments. And tell me suggest any topics for the next seminar, please. Other than that, thank you everyone for participating to the session. Good night. Hope you all took the maximum use out of these 2 hours. Okay, thank you. Please suggest other topics so I can prepare for the next seminars. Inorganic, okay. Okay, thank you. What are the things that should improve? I know today there were some technical issues. So sorry because of that. Screen got stuck multiple times. Okay. Anything to improve? Okay. Okay, then thank you very much for joining the session again.